Hi, I'm Ryan and I'm presenting abrasive jet machining for my materials and manufacturing industries class. What is abrasive jet machining? Okay, basically abrasive jet machining consists of shooting out abrasive particles at very high speeds at the surface that we desire to carve, which is called a workpiece. It's a material removal process with the help of abrasive grains shot out of a nozzle that removes by the action of impact erosion. In abrasive jet machining, a high-velocity jet containing abrasive particles is aimed at the workpiece surface under controlled conditions. The environment is very secured and closed so that this spray or these particles don't go out of control. And the high-velocity jet carves out the shape that we've predefined or the shape that we want to get from the material. The impact of the particles at a concentrated force to perform operations to cut through workpiece at speeds of 150 to 300 meters per second. The average speed of which the particles hit the workpiece ranges from 150 to 300 meters per second, depending on the application used. The abrasive grits are carried out in a high velocity gas stream. To propel these particles through the jet, we use a gas stream, which I will talk about later in the components. From the diagram here, you can see that the nozzle tip is shooting out these particles into the workpiece, and the particles have already made a semicircle shaped dent on the workpiece. Components of an abrasive jet machine. We have a gas supply, which is basically used to shoot out these particles to propel them out at high speeds. A filter, which is used to make sure that the fuel is completely clean. A pressure gauge to monitor the pressure at which the gas is allowing these particles to be propelled out. A mixing chamber, which is where the grits or the supply that we're putting into or injecting to be shot at the workpiece. A nozzle, which is where the grits come out directly off, and an abrasive, which is the material that we put into the machine. Gas supply. Gas supply is basically, it can either be nitrogen or carbon dioxide, and it's what's used to propel these particles out. A mixture of the gas that we're using, along with abrasive particles, are aimed at the workpiece under controlled conditions, which means the environment is closed and there is no chance for any particles to get out of this particular environment. And the gas is around shot out around a pressure of 2 to 8 kilopascals. The filter. The filter is basically used to clean the fuel supply so that dirt or other impurities do not hamper the progress of the process. We want the process to be neat as possible and with minimal impurities so that it's more efficient. The pressure gauge. The pressure gauge is obviously used to control the pressure of the compressed gas used in the abrasive jet machining, as the pressure decides the depth of cutting and the amount of force required for cutting. A more tougher particle would require more force, and we can regulate this using a pressure gauge. Mixing chamber. In a mixing chamber, the abrasive powder is being fed, and with the help of a vibrator, the amount of abrasives can be controlled. We want the abrasives and the gas to mix thoroughly in this chamber, and we can help or we can assist in the process of this mixing using an external vibrator. Nozzle. A nozzle is used to increase velocity of the jet. The velocity can be anywhere between 100 and 300 meters per second, as we have discussed already earlier. The nozzle can be adjusted accordingly for the angle that we desire for the cutting. In case we have a completely rectangular piece and we want to make a 45-degree angle across it, the nozzle would be adjusted before the cutting happens so that the abrasives can be shot out at that particular angle to achieve the desired end product. It's usually made out of tungsten carbide since it is subjected to a high degree of wear. The abrasives that we are shooting out do a lot of damage to the nozzle, which means the components that we're using to build up of this nozzle have to be pretty resistant to this kind of stuff. It should be able to withstand corrosion. Abrasives. The material we are putting into our abrasive jet machine to be shot out, they are basically divided into three main categories, which are aluminum oxide, silicon carbide, and glass beads. The rate at which these abrasives can be fed is controlled by the vibration, the external vibrator that we are connecting, the amplitude that it provides defines the feed rate of the abrasive powder. The common particle sizes for these abrasives vary from 10 microns to 50 microns. Smaller sizes are good. Smaller sizes are used for better surface finish and precision work. More intricate patterns and details can be achieved using smaller pieces, while bigger pieces that do not require as much intricacy can abrasive powder is controlled by the amplitude of vibration of the mixing chamber. The external vibrator that we connect to the AGM or the abrasive jet machine controls the feed rate of the abrasive powder that we have inserted into the machine. The gas and pressure can be controlled using a pressure regulator. There are three main categories of abrasives that we usually put into the machine. They are divided into aluminum oxide, silicon carbide, and glass beads. The average size of these particles that we feed the machine varies from around 10 to 50 microns for most use cases. And smaller sizes are used for more precision work and good surface finish. Basically, intricate designs and designs which require top precision can be achieved by using smaller grid sizes, and larger sizes are used for quicker removal rate. In pieces where we just want to remove or erode the surface as much as possible, bigger sizes are used, and the biggest size we have here are glass beads, which are 2500 in grid size, which is relatively quite large compared to aluminum oxide and silicon carbide, which have only 10 to 50 microns and 25 to 50 respectively. Orifice diameter. Orifice diameter refers to the opening hole of the nozzle, and depending on what material we would be shooting out, the hole of the nozzle would have to be an appropriate size depending on the material that we require. The working. The working principle of an abrasive jet machine involves the use of high velocity stream of abrasive particles carried by a high pressure gas through a nozzle on the workpiece. The pressure energy of the stream is converted into kinetic energy, and hence the high velocity stream is produced. These abrasive particles remove the material of the workpiece by micro-cutting action as well as brittle fracture. We can observe three different kinds of fractures generally, mostly two, but highly ductile fracture and ductile fracture are quite similar to each other. Brittle fracture is not very clean, and as observed, it happens due to a rapid process or due to a quick movement, while ductile fractures usually tend to take more time and it's a gradual process. It also occurs to something known as yield, which is how you get ductile fractures. And brittle fractures are what we are causing here due to these abrasive particles. We can watch a live demonstration of the AGM in this video, and I'll be showing it to you right now. So this is the gas supply of this machine. So you can see it's connected and ready to use. The pipe is connecting it to the nozzle at the end to shoot the material out. In between, you can see the gas regulator or the pressure gauge, which basically allows us to control what temperature we want, what pressure we want our nozzle to shoot out of. This is the control surface. The glass panes on the side act as a controlled environment. So they are setting the machine up for doing some abrasive jet machining. Grit is being fed into the machine, into the mixing chamber by using this small funnel. This is obviously grit that is very small in size, so we can obviously make sure we know that it's between 10 to 50 microns. Once the grit is fed into the mixing chamber, a key is used to tighten the mixing chamber so that none of the materials can shoot outwards. And the glass piece is removed so that they can place the workpiece inside of the machine. The workpiece is what we will be witnessing the action happening on today. And now the environment is completely closed, so that there is no chance for any of the grit to make it out of this closed environment. The distance between the nozzle and the workpiece is very minimal, so that the corrosion happening on the nozzle is minimal and the effects are more efficient. As we can see, the grit has been coming out of the nozzle, and we can observe the effects of this grit on the piece of glass that was placed there. On removing that glass piece, we can observe the effect that the grit has had on the glass piece. It appears to have made a fine hole through the glass. The size of the hole is directly dependent on the type of abrasive we have used inside the machine, and it seems to be quite fine, so it's used for that precision work. Moving on to the next slide. The advantages of using abrasive jet machining. A high surface finish can be obtained when we use abrasive jet machining, which means the particles are so fine that the surface that we're using it on can have such clean finish. It provides cool cutting action for glass and ceramics so it can machine delicate and heat sensitive material. In case we are dealing with material that is quite sensitive to heat or reacts differently in the presence of heat, this method is more useful since it does not produce as much heat as the other methods could. So materials that are heat sensitive can be quite easily worked on with here. The process is free from chatter and vibration as there is no contact between the tool and the workplace. In case of other machines, such as a lathe machine or something that we use direct contact to cut the material with, there could be external vibrations which affect the way the machine works. But in this process, there is a huge gap, not a huge gap, but there is a distinguished gap between the nozzle and the workpiece, which ensures that there is no vibration that can affect the process. The capital cost of an abrasive jet machining process is quite low, as the materials required are not too expensive or quite readily available. Intricate shape holes of brittle materials can be machined. Small patterns and extremely precision labor can be achieved using the machine. The abrasive jet process produces surfaces that have high wear resistance. Due to the nature of the abrasive particles that are working on the surface of the material, the finish is quite resistant to any wear because it has already been weathered and knocked down by the abrasives. Moving on to the disadvantages, less capacity of the process due to low material removal rate. The process takes quite a while as it requires a lot of time to remove material slowly. While machining soft material, abrasive gets embedded, which will decrease its surface finish. During the process of abrasion, tiny grit particles from the machine can get stuck into the finish of the surface, which will obviously be a problem to the final surface finish of the product. A dust collection system is a basic requirement to prevent atmospheric pollution. The dust produced by the whole abrasion process can be quite bothersome, especially due to the nature of the grit. And there needs to be a system in place to prevent this dust from getting out of control, which requires a closed environment at all times. Nozzle life is limited to 300 hours. Due to the nature of the abrasive action happening on the tip of the nozzle, The nozzle cannot go on without replacement. It needs to be replaced every 300 hours, or else the final product results will be quite incompetent. The process accuracy is poor because of the flaring effect of the abrasive jet. While shooting or projecting these particles out from the nozzle, the longer the distance is between the nozzle and the workpiece, the more the grit tends to flare out, which means move further from its original position. This might decrease its accuracy as it might not give us the exact same fine cut we want and might spread out to other areas. For example, in the video that we observed, if all we wanted was a glass cut, an additional byproduct would be the glazing of the glass around the hole. Abrasive powders cannot be reused as the sharp edges are worn and smaller particles can jam the nozzle. Once you've used an abrasive powder for the process, it cannot be reused as the abrasive particles have sharp edges that can erode the workpiece. And once they are used already, the sharp edges will fade away. And once they are used again, it will have almost no effect on the workpiece. The applications. It's used for frosting glass, ceramics, and refractories, and it is more economical as compared to etching or grinding. The process is much more economical compared to etching or grinding, and it is quite easy to use as observed earlier. Cleaning of layering of metals like resistive coating. It is quite easy to spray this material on a surface and clear out these layers that have built upon it. It's used for engraving registration numbers and toughened glass for car windows. As the pictures below indicate, the first one shows a frosted glass window, which can be achieved by using abrasive jet machining. And the second one, he is engraving numbers onto a toughened glass window using the process of abrasive jet machining. It can be used for cutting thin components such as germanium, silicon, quartz, and mica, cleaning surface from corrosion, paints, glues, and other contaminants. When these abrasives are shot at a surface which has some impurity or paint or glue on it, it can easily be removed by using the impact erosion. Thank you.